Hello, hello, and welcome to a little video about the Unit 4 review. Let's get started. All right, number one. In number one, the first thing I notice is a negative exponent. That means this negative exponent is on the wrong side of the fraction line. What we're going to do is we're going to take c to the negative third and we're going to flip it to the top of our fraction and make it positive. So let's see what that looks like. The 6 stays and so does c to the fifth. But c to the third gets flipped up top, 3 stays on the bottom. We can simplify this a tiny bit further because we can reduce 6 divided by 3, which is 2, and we're going to add the exponents c to the 8th. Beautiful. Number 2. Here we don't have a fraction, we do have negatives. However, first, let's do the product rule, which means if we have if we have two of the same bases and they have various exponents, we can add those exponents, which means for my x's, I can do 10 plus negative 3 because those are both x's. Yeah? And then for the y, I'll have 3 plus negative 3. Because those were the exponents for the y's. All right, let's add. 10 plus negative 3 is 7. And 3 plus negative 3 is 0. Well, y to the 0 is 1. And, well, anything times 1 is itself fantastic. Number 3. Oh, I see negatives, I see zeros. Let's get to it. All right, the 9 on top stays where it's at. P to the negative fifth tells us that I need to take that P, put it on the bottom, and make it a positive 5. K to the 0 becomes 1. On the bottom, N stays N, and don't forget it has that invisible 1. P to the negative third flips to be p to the positive third up top. And w to the power of 0 becomes 1. Okay. I'm going to rewrite it with less stuff. 9 times 1 is 9. I still got a p to the third. I got an n. I got a p to the fifth. And 1 doesn't change anything. Okay. Now, I have one last step. The step is that I notice that my p's exist on top and bottom. So we're going to use the quotient rule. The quotient rule means we're going to subtract those exponents. So we're going to do 3 minus 5. That's negative 2, which means our power belongs on the bottom as a positive 2. So 9 stays up top, and n, p to the positive 2, goes on the bottom. Last exponent one. Here we have the power product rule where we are going to pass out this power of 3 to everything in those parentheses. I am going to draw a little 1 for the 7 because it does have an exponent of 1. All right, let's do it. Why are those so thick? I don't like that. I need to fix my pen. There we go. Bidoop, 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 bidoop. All right. This becomes 7 to the third, a to the negative 18th, I'm multiplying, b to the negative 9th, and c to the positive 27th. We can take this a little further. First of all, I see two negatives, right? Got this negative 18 and I got this negative 9. And I do also have 7 to the third, so I can evaluate that. A to the negative 18th and b to the negative 9th mean that a to the positive 18th and b to the positive 9th should have been on the bottom of a fraction. 7 to the third becomes 343. And c to the positive 27th stays c to the positive 27th. Fantastic. Let's continue to number 5. In number 5, I'd like us to write an exponential equation for each of the following. All right, in 5a, I have a little table, and what I need to do here is identify two things. I need to identify the y-intercept, because that's A, and I need to find B, that's our pattern. Now, our y-intercept is what goes with 0. In this case, here it is, 0, 84. To find B, what we're going to do is we take two of the y's and we divide them. We always divide second number divided by first number. So we're going to do 14 divided by 84. And my calculator gives me a nice 1/6, which is perfect. That's my B. I got everything I need. Let's write it. F of x equals 84 times 1/6 to the power of x. Okay. Now, this is a graph. There's no table, but that's okay because we can create our own tiny table. We have this point right here, 0, 8, and I have this point right here, 1, 4. 0, 8, 1, 4. Got my y-intercept. Now all I need to do is find my pattern by doing 4 divided by 8, which is 1/2. So for letter B, my function is, f of x equals 8 times 1/2 to the power of x. Letter C. Now letter C is unique. I don't see a 0 there. However, it starts with 1. So we'll be able to figure this out. So first, let's find the pattern, because we can do that. And we'll find the pattern by doing 75 divided by 15, and we get 3. Which means the pattern is multiplying by 3. If I was to try to find 0, I would have to go backwards on my table. 0 would have been up here. Well, what's the opposite of multiplying? That's right, it's dividing. So to find this number here, we're going to do 15 divided by 3. And it's the 3 we got from our pattern. 15 divided by 3 is 5. So 0, 5 is our y-intercept. We got all our information. 5 times 3 to the power of x. Not too bad. I think as far as all this goes, the hardest part for everyone was these few problems. Okay, let's continue to number 6. In number 6, I'm going to complete the table first. And I do this by plugging in these x's into the function. So to find what f of x is for -2, I would put this into my calculator. And I got 32. Next, I'm going to plug -1 into x. I got 8. Then we can plug 0 into x to get 2. Then we plug 1 into x. We get 1/2. And we finish by plugging in 2 into x, and we get 1/8. These all give us points. This is -2, 32. This is -1, 8. This is 0, 2. This is 1, 1/2. And this is 2, 1/8. Which means we can graph it. Let's do it. -2, 32. Oops. Are we going by 2? Let me check my graph. Am I going by 2s? We are. Okay. So then -2, 32 is right here. -1, 8. 0, 2. And now with 1, 1/2, I'm going to estimate, and same with 2. There's my graph. Let's do the same thing with the second table. Just like in the first one, I'm going to be plugging in -2 instead of x and getting 5 coordinates. Okay. When I plug in -2, I get 3/16. That's a tiny fraction. When I plug in -1, I get 3/4. That's bigger, but still a small fraction. When I plug in 0, I get 3. When I plug in 1, I get 12. And when I plug in 2, I get 48. Let's graph. -2 3/16, I can barely draw it. -1 3/4, also barely draw it. But 0 3, I can do that one nice and solid. 1 12. I love me some whole numbers. And 2, whoops, that's 49. 48. That's not 2. There's 2. Fantastic. Here's our graph. That was ugly. Last try. Decent. I'm happy. Could be better, of course, but it could be worse. Okay. So far, not too bad. Most of what we'd had to do is plug things into our calculator and review on how to graph them. In number 7, what we're going to do is we're going to translate the function 3 units up and 2 units to the right. Okay, let's select 2 very nice points. I'm going to select the y-intercept because that's easy peasy. And this is a nice one here too. You know what? I'm going to do do I want to do 3 points? I don't. I really don't. I'll do it anyways. I'm going to do this half point here. Yeah, it'll be more accurate. I can't resist it. Okay, let's go up and right. Each one is going up and to the right. Let's do it. 1, 2, 3. And then to the right. 1, 2, 3. Whoops. It's only 2 to the right, silly. Silly Gooman. There we go. Maybe thicker pen is nicer. Let's thicken it up. Okay. Let's do the second point. Also up 1, 2, 3. To the right, 1, 2. And lastly, let's do our y-intercept. Up 3. To the right, 2. And here is, oh, ugly. Here is our new function. Number 8. The graph of f of x and g of x are shown below. If f of x equals 4 to the x, write the graph for g of x. Okay, well, g of x looks like it was moved down from f of x. Okay, so g of x is definitely 4 to the power of x and then minus, because we're going down. Now let's see how many we go down. What's a good point? Let's do this point and this point. The y-intercept's always an easy one to count. Okay, 1, 2, 3, 4, 5, 6, 7. Minus 7. Number 9, what we're going to do is we are going to just write the translations that are happening. Now remember, when we're going left and right, we add and subtract up top. When we're going up and down, we add and subtract outside. Okay, number 9, letter A. G of x equals 7/5 to the power of x, and I'd like to move it 100 units to the right. This is how it will look. 7/5 to the power of x. Then to move to the right, we're going to subtract 100 in the exponent. Oh, ew. Pick the wrong color. There we go. That's it. For letter B, we're going to translate it 13 units up. All right, so we'll rewrite the parent function. 13 units up is adding on the outside. Letter C, 1/4 times 7 to the power of x after 70 units to the left and 4,000 units down. All right. 1/4, 7 to the power of x. When we go to the left, we are adding to the exponent, so plus 70. When we're going down, we are subtracting outside of our function. Number 10 asks us, how can we tell if a function represents exponential growth or exponential decay? Let's write an example of each. Okay, so here's exponential growth. I don't know. F of x equals 2 to the power of x. Growth, that's not a t. Growth, because the base is bigger than 1. And let's do this, I don't know, 0.3 to the power of x is decay because the base is smaller than 1. Another way you can tell is if there's addition going on inside the parentheses, that's growth. If there's subtraction, it's decay. Number 11. Bridge City has a population of 15,000 people. That's how much we start with. The population is decreasing at a rate of 1.5% each year. Let's determine the population of the city after 10 years. Okay. So we're finding f of 10 because of the 10 years. Okay. The first thing we write down is the original amount. Well, the original amount of Bridge City is 15,000. Every equation gets a parenthesis and a 1. Now, based on the problem, it's either going to be 1 plus or 1 minus. Because it is decreasing, it will be 1 minus. And then we need 1.5% as a decimal. Now I know you're thinking, Gumin, 1.5 is a decimal? Alas, it has a percent symbol after that. Whenever that happens, what we have to do is do 1.5 divided by 100. We get 0.015. And we're going to set it to the power of 10. Now, when I put this in my calculator, I get 12,895.9. But that doesn't make sense. There's no such thing as 0.9 of a person. A person either exists or does not exist. So I'm going to round it down to 12,895 people. Okay. Cisco deposits $500 into a compound interest account. The interest rate for the account is 3.25. Write a function that represents the balance of this account as a function of time and determine the balance after 15 years. Well, I know it doesn't say if it's increasing or decreasing, but when you're putting the money into an account and you're earning interest, think about whether it's growth or decay. If you thought growth, you're right. Gaining interest is growth. We're going to find out what happens if Cisco doesn't touch their money for 15 years. They just forget about this account. All right, so we're plugging in 15. We start our equation with 500 because that's how much Cisco put in, and then a 1. Because he's putting money in and he's earning money on it, he gets a plus. 3.25 as a decimal is 0.0325. And I give it a power of 15 for 15 years. When I put this in, I get that Cisco has $807.83 in his account. Number 13. You bought a car for $40,000 in 2018. The value of the car decreases by 11% each year. The graph shown models this relationship. First, estimate the value of the car when it's half of what we spent. Well, how do we find half? We find half by dividing by 2. 40,000 divided by 2 is 20,000. So let's see, when do we hit 20,000? Bloop, 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 bloop. Beautiful, right here. And that looks like that's 6. 6 isn't a year. 6 is the years since 2018. So what you need to do is do 2018 plus 6, which gives us 2023. Next, let's estimate the year where the value will be 26,000. Okay. Well, let's see. 26,000, I think this is going by 2s, right? 2, 4, 6. This is 26. And let's see where it hits my graph. Ooh, right there. So that's between 3 and 4. Was it 2, 4, 6? Yeah. Between 3 and 4. So I guess we could, yeah, between 3 and 4. Now, between 3 and 4 means between 2018 plus 3 and 2018 plus 4. Let's write that down. All right. Plus 3 plus 4. So that means 2021 and 2022 between. Okay. Last one, letter C. Estimate what year will the value of the car be 8,000? Well, let's see. Oh, let's color code 8,000. What I want it to be. Purple. 8,000 is right below 10,000. It's this one right here. Let's see where it hits our graph. Okay. Ah, that's pretty nice. That looks like it's 14. Okay. Well, to find out, we do need to do 2018 plus 14, which is 2032. Fantastic. If you have any questions, please feel free to ask me or whoever is helping you out to study for this. Otherwise, good luck studying. Have a wonderful rest of your day. And don't stress too hard. Bye.